Good morning. My name's Neil, and my role is basically a technical marketing director at Fusion.io, but my background is in engineering, just to qualify some of these slides. So what I wanted to do today was just talk about the evolving of Flash and how we're seeing more and more Flash as a means of basically accelerating data in our current data centers. So if we give consideration to society, if you like, it's very clear to all of us that over the last few years, the whole networking and the convergence and the integration of devices has just exploded. And so with that, we also see, of course, the retention of data, the gathering of data, and really the need to try and make use of that data as well. So an interesting fact is, really since the dawn of time, if you like, up until 2003, society as a whole created 5 exabytes of data. What we're anticipating, at least with Ericsson's, is anticipating that is from 2014, we're looking at creating 5 exabytes of data every 10 minutes globally. And that data has to go somewhere, and it clearly has value. And businesses wouldn't collect that data, and they wouldn't mine that data and try and extract value out of it if it wasn't worthwhile. And that data has to go somewhere, and clearly at the moment, predominantly it's sitting inside data centers. And we need to look at the efficiency of those data centers. Moving forward, predictions are 50 billion devices, globally connected by 2020. So, even your car, can tell tales on you about, how fast you're going in terms of speed, or whether it's raining and the windscreen wipers turn on, whether it needs servicing. Just from PDAs, so on and so forth, we see that this whole connectivity society that we live in, everything networked in society, is cause for us to look at ways of managing data more efficiently. So these facts come in from the US, but the global data annual spend is phenomenal. If we start looking at the cost of this, it's something that has to be dealt with. So software, 254 billion annually, networking 24 billion, storage 32 billion, servers 51 billion, services as well, $832 billion. Software, for those of us wise enough to use open source, perhaps less of an issue, but still an amazing amount of money. Power and cooling, equally, prevalent to us at 61 billion. So a little over $1.25 trillion in costs that ultimately affects all of us. And there have to be ways of approaching this, both from a cost point of view, but also from a performance point of view as well, which is where Flash becomes quite interesting. So, why can't we? Why do we face the problems we have? Why, if we follow things like Moore's law, for example, why isn't data going quicker? Why are we struggling? Why are data centers generally considered expensive and inefficient? Who's the culprit? Well, it's very simple. The fact is, we're using 150-year-old technology. We're still scraping data and information onto rotational media. And whilst, these days we do it with magnetism onto disk drives, it started off, of course, with Thomas Edison. And so we're limited by rotational latency. So, Newtonian physics, ultimately, a spinning platter, or lots and lots of spinning platters, are going to affect us. We can only get data in and out of those drives at a certain rate, and we can aggregate them together to try and get more I/O. If we're in random environments, of course, where we have to move disk heads to seek data, then it destroys our data performance. And ultimately, that dictates a lot to us, and it's driven inefficiency. To try and counteract the problems of disks, we've thrown more disks at it, more spindles. Let's get more I/O. Often then getting far more capacity, so oversubscribing capacity for I/O, which is inefficient, costs money to power, costs money to cool, and so on. We throw engineering at it. We try and play clever tricks with disks. So we introduce fiber channel SAS and so on, but ultimately failing to take into account the rotational latencies that we experience. We employ database engineers to try and improve our database performance and so on. Ultimately, generally for small gain. The people that have really been laughing through all of this, of course, are the disk vendors, the incumbent storage system vendors, who equally will throw some degree of performance-based tuning at this, but forgetting the fact that it's the disk that's the problem. So I think certainly with Fusion IO and a lot of flash vendors, is that we consider disk these days to be a capacity product. It's there for storing data. It stores large amounts of data very efficiently. What it doesn't do, however, is perform. And that's where if we start looking down this road, we can start seeing ways of perhaps introducing flash as a more mainstream product. So we have to ask ourselves as well, why are we still using disk? And it's cheap. That's one way of looking at it. And there hasn't really been an alternative. We've gone for faster disks, faster RPM. We're reaching the limits of that in reality. We have different disk interfaces and so on to try and eke the best performance. We use different protocols, such as fiber channel as well, SAS and what have you. But really, the culprit was two things. One, that there was no real alternative other than DRAM, which is incredibly expensive in terms of capacity, both to run and to purchase. So we had to bear that in mind. Whilst there was only disks, we would load data into memory and try and feed CPUs via memory. So, whilst these CPUs are running fairly idly and not really returning your investment because they're waiting for I/O, the only way we could try and speed that up was to throw more disk in it, more servers at it, potentially therefore more DRAM, more CPUs, and so on. But then, as we all know, when cameras, digital cameras started coming along, USBs and so on and so forth, CF cards, SD cards, we started seeing consumers drive the need for NAND flashed. So when we say NAND flash, solid state, let's just leave it at that at the moment. We're not going to go into the details of flash so much today. So clearly, we all have smartphones, most of us may have iPads or alternatives and so on. It's mainstream now, and that's brought the price down, which is great news. So if we look at flash as a replacement for memory, as opposed to a replacement for disk, then flash becomes quite interesting. So if you use flash as a persistent storage medium that is almost as quick as DRAM, but is higher capacity, 100 times the capacity, and way cheaper to use as that storage medium, that can feed CPUs as fast as the CPU can process that data, then flash starts becoming a really interesting alternative for us. Not only are we going to drive down costs in a number of areas, we're also going to see performance go through the roof, which is what we want as well. So if we took an idealistic approach at data centers, and if we went for the all-flash data center, which is a bit of a nirvana in reality at the moment, but certain customers of ours, such as Facebook, are going down this route, then we do look to see, around about a $250 billion worth of savings. What this doesn't take into account is actually the increase in productivity that your businesses will have as a result of being able to turn basically data into information far more readily than you can do with spinning media. So not all flash is equal, and I think that's something that's important to give consideration to. When we look at flash versus disk, I've kind of highlighted that. I don't want to go into too much technical depth today as such, but we can see the weaknesses of spinning disk. High capacity, which is great, but they're expensive to run. They do have a high failure rate in a rated environment, which is not ideal. And if you then look at SSDs, which is, of course, the solid state that we're all commonly aware of, they're not ideal as well. They have their own limitations. So what an SSD does is basically, it's almost augmenting mechanical storage, i.e. disk-based storage. So you have flash in a drive, and in front of that, you place a disk-based interface, so a legacy interface, which hobbles flash. It's not ideal. So you'll see some performance improvement, for sure, because there's no rotation involved with the flash. But because you're using a legacy interface, such as a disk-based interface like SATA or SAS or fiber channel, you're actually not getting anywhere near the creativity in terms of integration and performance that you could do with flash if you wrote to it natively, which is essentially what companies like mine do. So there has been some success, in fairness, with SSD in the enterprise environment, but generally what happens is consumers will treat them like disk, rate them with parity and so on, which actually exacerbates failures and introduces performance issues with SSD. If you use flash natively and treat it as a memory, in other words, place that flash on a PCI slot as close to the CPU as possible, you can feed massive IOP at very low latency to the CPU, improve the CPU's utilization through the roof, potentially reduce CPUs as well, because if you have 4 CPUs running at 25% each. It's quite arguable that you could get rid of all of those and use one at 100. It's a very simplistic term, but you get the idea, and there's clearly cost savings there, as well as license savings and so on, which we can look at in a moment. So, yeah, there are two tiers. You can use Flash as disk, or you can use Flash natively, and if we use Flash natively, we'll see a far more scope for evolution here. A couple of things. We also have to take into account that we're working at an enterprise level here. So SSDs fundamentally were designed for consumer environments, not for enterprises. So they're actually kind of over-engineered as well, which doesn't help. And we can see that here, that there's multiple agents involved in this environment for the transfer of data, because we have the host CPUs, we have SAS controllers involved, DRAM involved, as we go through and try and access that data and make use of that data. So there's a number of context switches here as well that doesn't help, but also multiple traversing different agents to see that data. So this actually hobbles Flash, slows down Flash and introduces errors. If you write to Flash natively, in other words, virtualize that Flash, then you can see on the right-hand side, it's a lot simpler. And what we want is simplicity. Speed and so on is great. But if we're looking at an enterprise environment, if we can complement that with a simple, reliable infrastructure, then that's perfect as well. To give you a rough idea here, this is some SSDs, it doesn't matter who, but a prominent SSD manufacturer that went up against some of our cards in a bake-off here. And what you basically see here is where SSDs start to let themselves down when you raid them in enterprise environments. So very, very quickly. The mere process of these SSDs having to manage Flash causes I/O to basically to stop. So the whole RAID environment stops. So what that means is, of course, if there's no I/O, there's no performance. And if you say have 100 transactions, and one of those transactions is missed in Flash, and you have to go back to disk to grab it properly, what's going to happen is your performance is going to be dominated by that 1% miss rate. And so it all comes crashing down. And you can see that here. It's not acceptable to place these SSDs in an enterprise environment where we need not only a consistency of performance and latency, but also reliability. Going far quicker than I thought. Okay. Just to save some time, we kind of mentioned it, but what this really does just highlight to here is that there's multiple failure points here. It says, particularly in the RAID controllers where you've got firmware, so on and so forth as well, supercapacitors, batteries, but that's no place in Flash environments. So if we're going to look at safely evolving Flash into an enterprise environment, it has to be reliable, and then the costs, so on and so forth, we'll look at in just a moment. So if we're looking at Flash natively, what we tend to see is, and it's what data centers also want, so consistent latency that's low. To give you a rough idea, one of our intermediate cards, just to say as an example, can replace 1,200 disk drives from a performance point of view, and can run at 15 microseconds latency. So that's it's an order of magnitude quicker than standard disk drives. We need the reliability, we need the endurance, we want lower power consumption. So the equivalency of 2 fiber channel drives a year in terms of power consumption is a lot lower. We need to up density. We don't want huge data centers. It's simple as that. The ones we do need to be efficient, powered and cooled effectively, and so on. And if we start answering those elements, particularly with disks, that are actually causing those data centers to sprawl out and actually remove those as far as possible, then these costs come tumbling down. And also introduce a lot of predictability in terms of performance and scale out as well, which is a slightly separate subject to now, but one that's still very important. So not all Flash is the same. I think I said that just a moment ago, but you can use Flash natively, and by doing that, it means we can interact with Flash cleverly. We can use it as a block device, as a standard disk, or we can use it as a caching device as well. But we can go a step further. If we start introducing APIs into native Flash, then we can start integrating Flash not only to operating systems and to applications, but we can start bypassing the inefficiencies and work more closely with the OSs and the applications to improve Flash even further. It's the nirvana of performance beyond what correctly architected Flash already gives us. To give you a rough example, here we have MySQL. And it's here that we see, this is actually pretty interesting. So, well, if you're technical, but just to give you an idea, In an XFS environment, on the left-hand side here, we have two options how we can write with NoSQL, basically. We can be safe and use double writes, ACID mode, or we can be unsafe and get better performance, but risk data corruption. And that's what we're seeing on the left-hand side. So roughly double the performance, but dangerous. If you then write to Flash natively, we can change things. With any file system, there's a penalty for the simplicity and the ease of that file system, and that's an overhead in terms of attacks, if you like, on I/O. If we can write a file system that integrates with Flash more successfully or more readily, like DirectFS, then what we can do is we can actually see performance improve notably, especially if we then start using APIs such as Atomic I/O that integrate with MySQL. And you notice that we're basically getting the performance in ACID mode, in non-ACID mode, the performance of it being in ACID mode being the equivalent of non-ACID mode in other environments. So, what this means to me with 35% more performance is I can get the workload of what was 3 servers down to 2 servers. I can get twice the endurance, I get half the write load, which in a Flash environment is quite important. There are longevity management challenges with Flash. But what we're seeing is 35% more performance beyond native Flash. Just conscious of time here, so I'm just going to spindle through these last couple of slides. So if we start looking in the data center and hyperscaling out with the larger examples of this, like Facebook and so on, their requirements are fairly straightforward. They want performance, low latency, and they want consistent latency. In other words, predictable performance, which you can never get with disk drives unless you throw a lot of money at it, and even then it's debatable. High transactional throughput. We want simplicity above all. We see a lot of servers in environments where we architect our cards for, where the server itself is incredibly simple. It's essentially a throwaway commodity item. They'll recover the Flash, but beyond that, they don't care about the components inside. It all becomes one commodity item, and it's about density. In 1.5U, can I get 24 terabytes of storage, for example, with what we do, and scale that predictably and scale that performance predictably, whilst reducing that cost overhead massively as well. And then we see our people we talk to start asking us questions like this: okay, so we can scale into the data center quite readily. We understand the performance, we understand the density drop, we understand the licensing savings, the power, the cooling, and so on. And then we can start asking questions about how we account for the data center. Are we starting to look at transactions per dollar, per U, per watt, so on and so forth, clearly in many cases. Can you give me the reliability? Can you give me the endurance? So on and so forth. And the simple answer is we're on that cusp. Now, is it a case of cost? And to give you an example, per slot, if you get 3.2 terabytes at the moment with our scale-out card, but it's the leading example, so I'm trying not to keep this anyway salesy. But $3.89 per gig is a very simplistic way of looking at things, but it is the de facto way of looking at capacity and stuff with data centers. But that's coming into the realms when you start looking at all the other savings, where that's becoming quite interesting. And really, as I was saying, when you can start to get 24 terabytes per 1.5U with predictable scale out, then the argument for having Flash predominantly, if not entirely, in data centers is there and on the cusp of being adopted, and certainly has been by our biggest customers, as I mentioned, one of those being Facebook. I think that was it.